everybody. Welcome to another Haas Talks Foss. Today I'm here with Bruce Momjan from Enterprise DB and from the Postgres community. Now, Bruce, you have been around the database space for a long time. Oh, longer than I have. I've been around for about 25 years in the database space, and you have several years on me even. So I read on your website and recently, in one of your blogs, you mentioned 32 years in the
Yeah,
database space.
yeah. I started with databases in '89 as a just as a developer. So I was writing database applications. But pretty soon after that, I actually tried to write my own database in C, and I kind of got to the point where you you write your own database using SQL commands, but then there's this recursion problem, and then I gave up because you end up writing the bootstrap code in in SQL, but then you don't have any SQL to bootstrap it, so it was just too confusing. So then I wrote an SQL engine in shell script called SHQL, which is I think linked on my website. And that was my, claim to fame in the SQL world, and still until I started with Postgres. So yeah, for some reason that just has always resonated with me. I remember flying to Australia with my wife on vacation, and I was reading an SQL book by Groff. It was the author, last name. And I remember just being really fascinated about how this SQL thing worked and being really excited. And my wife complaining that I wasn't talking to her. I was reading a book on the plane and stuff like that. But I said, I'm on vacation, but I want to, this opportunity to kind of do research while I'm in the plane. So, yeah, for some reason, I've always been interested in it, always been interested in how it worked. Got interested in Postgres because I was curious how the optimizer worked. How does this thing, I was in Formix Ingress guy at that time. And of course, you can't see the code, but with Postgres, you could. So, yeah, just kind of digging in there and sort of seeing how it worked. And then working with one of our early developers, Tom Lane, who's a core member now, and kind of dissecting the optimizer, figuring out why it's so slow. I remember some long phone calls on the weekends doing that. So it's been a long, long time. For some reason, it just resonated with me. I don't know why. The funniest thing was I was with Linus Torvalds at OSCon probably 12 years ago, and he came up to me and said, he said, I always thought like people couldn't get excited about databases. Like operating systems, I can get open source people excited, but databases, I didn't think that was possible. But you showed me I was wrong.
Well, it's a great compliment, right? Like
Yeah.
getting excited about something that most people find boring.
Exactly. It's not for
And
everybody, but yeah.
yeah. Well, this is an interesting topic though, because I've noticed this where, the we've tended to think, or as a developer community, I guess, has thought databases are uncool for a while
Right.
now, and so they don't want to deal with them, right? And so they continually kind of like put, whether it's ORMs or abstract layers, or try to just get out of thinking about databases as much as possible. And I think that that comment there kind of shows that a lot of developers just, databases are not cool. How can you make that exciting? Now, I'm like you. I do get excited about performance things and database features, and changes. So it's weird that other people don't. To me, I don't know if that's the same to you. You're like, you don't find this interesting? This is really interesting to me.
So my wife hates. My wife took a computer class when she was in college, I think, and she hated it. Right? So I'm kind of used to being around people who aren't really excited about what I'm excited about. I mean, I'll give you a really crazy story. I was in high school, probably high school, and we used to wait for the bus, and there used to be a a railroad line that went by near the where we waited for the bus, and it was the early morning, so the trains are going back and forth, and train would go by, and we'd stand as a group. Oh, look, there's a train. And I guess I did that every day. Like, oh, there's a train. And it never occurred to me that somebody wouldn't be interested in pointing out that there's a train going by. Like, to me, that's exciting. right? There's a train. Look at that. Isn't that cool?
Yeah, yeah, yeah.
But everyone else, I remember once we were at, and the train goes by. One of the people says, "Look, there's the train," and everyone laughs. And I'm like, I don't understand why that's funny. Like, yeah, but they were laughing at me because I think it's interesting and nobody else does. So yeah, I'm always been the oddball. I watch NHK World from Japan. I watch stuff that people come in like, what are you watching? And I'm like, well, it's interesting to me, So I guess I've just been that kind of person.
But isn't this where it's interesting because we've started to enter this space from a database perspective and a technology perspective where the interest is in that application development, and so we've done a lot to automate, to build out the technology of the databases to make it more self-managing, more tools, more automation. But at the same time, the developers care less and less about databases because they don't have to. Isn't this creating kind of a gap between the knowledge that people have when they need to troubleshoot or fix, which honestly still happens, and their capabilities to actually manage and do those? So it makes people who do care more valuable.
Yeah, I think it's really a question of how you view the life cycle of what you're doing, right? So if you're just trying to get from A to B, which is what most developers are trying to do, then the database can seem to be this impediment, right? Because you got to create the tables, you got to define the indexes, you got to sort of set up the schema, and developers just want to get from A to B, and I just want to get that job done, and I want to see the pretty stuff on the screen. But when you think of the life of the data, the time it's going to need to be used, the life of the application, then you really kind of do need to spend time at the beginning a little slower, right, to sort of set up what you're doing. I think the big difference is that most people, if you're playing a computer game or you're like making a spreadsheet or whatever, you just kind of like, I'm just going to do it, and I'm going to get it done for my project, and I'm going to leave. And what we find, I think, is that because databases by definition are static, or they're stateful, right, is the term. There's just this life of what you do that lasts far beyond the time you're needed. So it's really the life of data for me that I think makes people scared, and people who don't understand the life of that data fall into these kind of pitfalls where they're using RMs. They're just throwing the data into NoSQL. They don't care about what the schema is. They don't care about what the future application is going to need the data for. They don't care about, they just want to get the job done. But if the application wasn't stateful, you can live that way, right? Like I tell people, if your text editor dies, you just restart it, right? No problem. There's no state in the thing. But when you're talking about something that's going to live for a long time, then yeah, you got to do the upfront work, I think.
So you think this is short-term thinking? Like, just because they're like, I have, a deadline to develop this, to get this out the door, to get it out to the users. I'm going to do whatever I need to do to get it out there.
I think a lot of it is, like, let's look at the RM case or the NoSQL case. They're great at getting at the data in one way in the how the application wants to see the data today. That's how I'm going to put it in, and that's how I'm going to get it out, right? But you're not thinking about how are other applications going to get that data? How am I going to get it for analytics? How am I going to handle cases where the application needs change and I have to change what data I'm storing? So then over time, things become a lot more complicated. I mean, I think the classic case for me are object databases. Now, you might not have been in the space when object databases were big, but they were supposed to be the sort of mapping between object languages like Java and databases. So you were just going to take the Java object, you're going to put it in, you're going to take it out, right? We don't hear much about
like JSON, but
right.
An object, right?
But objects, right? And
similar.
If you look at where we are now, we don't see that anymore. We don't hear about object databases anymore because in those cases, the data was literally exactly the same as the application stored it. So you couldn't really get at the data in an object database very easily. You had to really write a program. And if you had to write a program, the program had to really know all the intricacies of the application to even get the data out of the database. So it was the kind of case where it sounded great. It maps right directly to object languages to the database. But because the data is stateful and because the needs of of what you want to do with that data changes, whether it's analytics or application changes or just other applications, then the whole object database thing kind of fell apart. So that's why you start to use our ORMs, because at least that gives you a layer over the actual data. You can map the layer to change as the application changes, but the data is still in a form that can be digested and analyzed by other applications because it's in a sort of a discrete form that's not tied directly to the application. That's I think that's why people aren't excited about it, because they're just, you know, I feel for application programs because to learn SQL and have to do, you know, an application where people are changing specifications all the time, and you know, that's why I think NoSQL's gotten popular for a while there.
Well, I mean, I think that, you know, where you're seeing this whole new generation of purpose-built, you know, databases, whether, you know, you've got graph databases, you've got time series databases, you've got, you know, the new SQL, which is kind of old SQL, but with, you know, distributedness. You know, you've got, you know, several different, you know, types of databases that are starting to crop up into these companies. And really what I see over and over again is, you know, developers end up choosing the one that is easiest for the job. So maybe it's the short-term thinking. They put it out there, and then unfortunately somebody has to deal with now 15 different database engines that all have different formats, that all have these different things. So now we have the whole new data lakes and, like, you know, all of these different, like, you know, technologies to try and wrangle all these different database engines. Which is an interesting space, because now we've gone from, you know, hey, I put everything in a centralized, you know, system, you know, try and, you know, keep everything uniform, to use whatever you can to get the job done. And now we're going to create extra layers of complexity on top of extra layers of complexity to try and deal with all of the sprawl.
Yeah, in fact, I just gave a talk at Postgres Vision, I guess it was Tuesday, talking about data horizons, because with Postgres, because, you know, in the early days, data was coming into a database either through punch cards or dumb terminals, or teletype, you know, the old way back. But then if you look at the data ingestion methods that people have now, it's, you know, it's web browsers, it's mobile apps, it's GIS data, GPS data, it's telemetry, Internet of Things, social media, right? And you need analytics to come out of it too. So the idea that am I going to be able to use the same database for GIS as I'm using for JSON, as I'm using for full text search, as I'm using for Internet of Things, right? A lot of relational systems just can't handle that. If they can't, then you end up with all these separate data sources. But then you've got to govern those data sources. You've got to figure out how to integrate them. You've got to figure out how to have them backed up consistently. You got to figure out how to delete the old data you don't want anymore. So you get that data silo problem, which I've heard a number of people complain about. And one of my interesting aspects of the talk I gave was to try and say that Postgres being object relational and having, you know, special ability, special indexing, special data types, and so forth for GIS, for JSON, for full text search, for you know, high ingestion data. So you've now got a database which is relational, but it knows it has specially code to handle a lot of these other things, and it does. A lot of the problems do go away. You don't have as much of an integration problem,
right?
That you would.
Yeah, it's the Swiss Army knife approach, right? It's to try and give you enough to get the jobs done you need without having to break out and go into completely different angles, then try and bring them all back together at the end.
Yeah.
It's where you want to pay the pain, right? You know, it might be a little bit more upfront work to actually design a schema, to think about how to use, you know, Postgres, you know, to solve these problems, as opposed to just saying, well, I'm going to go get this all off the shelf solution that is built for this thing, and then later on have to figure out how to get the data back together.
And I think I had another blog entry about this where, new data, really a lot of the innovation in IT usually starts in homegrown or custom, you know, discrete applications, right? So I'm doing AI, right? Okay, I'm going to have a separate AI tool chain for that, and it's going to be a separate thing. Or I'm doing full text search, and that's going to be a separate thing. Or I'm going to do GIS, that's going to be a separate thing, right? But over time, as those data needs mature, you start to see them moving into the database, because then we kind of know, okay, we kind of know what full text search needs, we kind of know what GIS needs, and having this separate thing flying around to store that is just a headache, because I got to synchronize it. I've got to make 2 calls to get the data to bring it together. I have no data governance real easily between the two. So yeah, I think that's basically the case, that over time relational systems sort of subsume a lot of those satellite needs, because a lot of times it's more efficient to have it in there.
Well, and also probably people look at it and go like, this really looks like data that should be stored in a database. And they eventually, oh yeah, we should do that. That's a good idea.
Right, but you have to have special indexing. You can't just use B-tree for GIS data, for example. You have to have special data types. You have to be able to store really non-relational data, right? You're bundling XY coordinate or longitude latitude. You're bundling a text document in a field, and you've got to be able to index that efficiently. And if you can't, then you end up just trying to smush it all into some kind of pure relational structure. It's going to be a complete headache. You're going to lose so much of your data integrity, and it's going to be a headache, and you're not going to really be able to get at it or index it cleanly. And then you say, oh, I need a separate thing, right? So you're kind of going back between, do I want a separate thing to do this? Sometimes you need it. Sometimes, for example, even with Postgres, we don't have 100 foreign data wrappers by accident. There's legitimate cases where you might need to use a Mongo with multi, or Cassandra with multi-server, or you might need to use Hadoop, or you just might have legacy data out there. You might use Internet of Things, and your data ingestion is so high that you just need a separate data store and a relational data store, and that's okay. Yeah. But again, you can communicate with that typically through Postgres at least, and kind of bring that data together in a unified way.
Yeah, and I mean, I think as the developers start to look and choose these different technologies, they're looking for the easier solutions. You mentioned we talked a little bit about the short-term thinking, but that's made a lot of the vendors and a lot of the projects that are working on these databases look at ways to make things easier and to automate and drive towards making sure that not only is the data secure by default, it's available and it's performant. And, I knew that you had posted a blog recently that talked about, hey, this drive for zero downtime is actually making the downtime issues more complicated. And this is where it's kind of interesting as I see this kind of push for easy, this push for, these individual, systems to handle more and more, because, developers just want to choose that, thing that's going to make, their project get out the door quicker. We've pushed more towards that, availability and automation to keep things moving. But you had talked here about that does make things more complicated when things do go awry.
Yeah. So I for some reason, I guess I've always been interested in the risk analysis. I'm not sure why that is, but I remember being on the Usenet forum. I think it was called Alt Risk or something, Comp Risk, something. And they used to, this is obviously in the 90s, and they used to post sort of risk analysis, not only of IT stuff, but in general, risk analysis of why disasters happen, why things happen. And then probably a big turning point for me was a article in the Atlantic Monthly, again, it was in the 90s, about the ValueJet crash out of Florida. And you may not remember that one. But
I remember it.
Yeah. So it was a case where They had put the oxygen canisters that are used to give oxygen to the passengers if they were to lose pressure in the cabin. They had needed to move them from one facility to another, and they put them in the cargo hold of the plane, which is a no-no. The plane took off, and within a couple of minutes, it exploded, and I think everyone died. And they did some risk analysis of why that happened and so forth. But what you basically had was a safety device, oxygen canisters, killing everyone on the plane. And you're thinking, well, is that really a safety device or is it not a safety device? And the fact is you can't really label something unequivocally as a safety device or not safety device because every safety device technically has the potential to cause some kind of harm. If we look at the Chernobyl accident happened during the testing of the reactor at low power. You look at 3 Mile Island. Problem there was a safety device malfunction. So you start to look and you say, well, okay, if I think of recent nuclear disasters, for example, safety systems seem like a negative, right? they're actually causing problems, right? And that's when I started to extrapolate that out to pretty much all actions. Like if there's another great story where somebody's in it, the fighter jet pilots are obviously heavily trained, and when they see a problem in the plane, the first thing they're taught is to do nothing, right? Which seems like crazy, right? But they basically said the first thing you should do is figure out, is my plane still in the air? And if the plane's still in the air, then you're probably okay. And you should basically look at what's going on and take appropriate action. But what we don't want you to do is to just react right away. In certain circumstances, you have to eject or whatever. But in a lot of cases, the plane is just fine. And here's some things you can do to mitigate the problem. If you overreact, you can make the problem a lot worse, right? So in the same way with databases, I have a bunch of, I think there's 2 or 3 blog entries really talking about this particular topic, but the most recent one talks about multi-master replication, which a lot of people feel is a great uptime capability system. And, one system can go down, the other one keeps going and so forth. But those systems are very complicated. And a lot of times you have more problems with a multi-master system than a single master, master replica or master standby system. Because multi-master systems are very complicated. They scale, they have weird performance characteristics. One system goes down, it can bring down the other one. So it's not a panacea. Another classic case for me in the IT world are RAID cards. RAID cards in the 90s and even 2000s were the big thing. And everyone had these fancy RAID cards and, you have memory on them and there's a battery and so forth. Well, a lot of times the disk drive problems were caused by the RAID cards. It wasn't. A lot of times the systems went down because of the RAID cards, but the RAID cards were there to keep the system up. But they're very complicated. The software in there is very complicated. They're dealing with different drives, different manufacturers, different failure modes on the drives. So I guess, what I was kind of trying to get at is that simple a lot of times is better because you can analyze a simple system. You can figure out if something goes wrong, how to recover it. That is not so easy as the systems get more complicated. So sometimes you make the system complicated to try and reduce downtime, but sometimes the complexity itself can cause a lot more unplanned downtime than you actually saved when you started.
Yeah, there's definitely a balance there. I mean, especially now when you look at like these, companies and their data centers and applications that might have hundreds or thousands of databases that they rely on. And so you've got, not like the same. They're all potentially unique. They might all be different technologies. And, there's been this drive to try and simplify and automate things. And what's really interesting is if you look at a lot of major cloud provider outages or SaaS outages over the last couple of years, a lot of them are caused because someone takes something that is seemingly innocuous and it has a bug because it wasn't fully tested, and then they automate that across 10,000 nodes. And now instead of having a single system that might have gone down or gone through testing and, hey, I need to fix this one, whereas 99% of the infrastructure stays up, the whole infrastructure goes down because that one change was cascaded through. And it's an interesting space because there is a lot of that automation which is needed to manage at scale in a lot of cases, but it's also making things much more complicated. But I think at the same time, I'm noticing that, and this gets back to the original point I was mentioning about, like, kind of the database, developers caring about databases or that skill level. I've seen the skill level kind of drop of people who understand that even like some of the basics around performance tuning or optimization or, database design, because these new applications, these new functionality, these new technologies, kind of hide the complexity from them. Oh, we're going to spin this up. Click the button. Hey, look, it's off and running. I'm done. And now when those problems do occur, they might have been fixable if you knew the systems better and understood the technology, but now it takes longer, or you have to have specialized skill sets in order to fix them.
Yeah, I mean, there's no question that things are getting, more layered, more complicated. The containerization, virtualization, cloud obviously are, almost guaranteed to add complexity or whatever you're doing, because you're not dealing with physical hardware anymore. You're dealing with this abstraction that's kind of down there, and a lot of people fix it by throwing additional hardware at it. I mean, the types of things that we used to, the best example, and I have another blog entry about this, but the best example is, you really don't write a whole lot in assembler anymore, right? Because even though it might be a little faster, and arguably it isn't anymore, because compilers understand the CPU pipelining better than a human could. It's not necessary, so that languages get more abstract, they get more powerful. But then you can go too far. I think a lot of the Java criticism is that Java was starting to be placed into areas that maybe it really wasn't kind of made for. It had gotten a little too far in the abstract to kind of do some of the stuff. And Claire, I think EDB, when we started, I think we had a JBoss web server. And we had gotten to some kind of, every Sunday night it would be rebooted or something, or some, instead of fixing it, this was back in the mid 2000s, but, there was some crazy, and eventually, they got rid of it, but trying to fix that thing and diagnose what was going on, was, compared to an Apache situation is, it's like night and day, right? So, yeah, I there's a sense that some people fix it by throwing additional hardware at it. Sometimes, you have to say, "Hey, I took a wrong turn here. I need to go back."
Yeah.
And retool what I'm doing. And where's the right level of abstraction for people? Is it something like SQL, something like R, something like Python? Is it something like Java, or is it something like C? Like, where do you go on that continuum, and how much do you understand of it? I mean, in a lot of sense, the SQL language allows you to abstract out so much, because it's a declarative language. You just say what you want, and you let the optimizer figure out how to give it to you in a way where the data can be changing. You can have new indexes, and so I think a lot of people miss that. The idea that you can now just ask for the data and not have to worry about how it's getting to you, and how and I think a lot of application developers kind of miss that, and they end up making their applications harder because they have to join in the application, they have to do analysis in the application, because they don't maybe understand how to get at the data in a way that pushes the problem to someone else. Push the problem to the SQL engine is usually the best bet, if you're dealing with lots of data. I think that's why the SQL language has, maintained that sort of pristine thing, because you're dealing with a lot of data. The data's changing all the time. You've got a lot of concurrency. These are very hard problems to solve in an application, but they are solvable in a database, and that's why I think we're still talking about SQL. 50 years after it was originally sort of specced out.
Yeah, yeah, yeah. And I mean, sometimes I wonder if if you were going to start SQL again, would you do the same things that we, the same decisions? Like, what decisions would change?
Right. So when I originally started with relational databases, I used Quell, which is the Ingress original language from the Berkeley 70s Ingress. So I didn't learn SQL until I went to Informix, and that was in the mid 90s, maybe 93, 94. So I actually used the pre-SQL language, and in a lot of ways SQL was a better language. It had subqueries. The Quell language had some really weird scoping, particularly for aggregates. It was just bizarre to really understand. So yeah, I mean, SQL is not perfect, but it's evolved over time, and they've made some changes. Null is going to always be an amorphous argument of whether we're doing there. Yeah, if we were to do it again, I don't know. I don't know why. I don't know that they would do anything super significantly different. Yeah, I'm not sure what I would change.
Well, it's interesting because most of these, vendors do try to reinvent how to access data, but eventually they come back and then bolt on an SQL, mechanism at the end, right? So you start off with, oh, this is all going to be accessed through this fancy API that's going to match what developers want, and then all of a sudden, 2 years after that, they're like, oh, and here's this new, SQL interface for us. So they keep on coming back, don't they? They just,
So yeah, I got a funny story for that. So, I'm a big original Star Trek fan. I used to go to the conferences in the 70s, and there was one Star Trek episode where there's this like alternate universe where there's like a good Enterprise and a bad.
Oh, the mirror universe.
Mirror, right.
Yeah.
The bad Spock, whatever. And, and the good people go to the bad Enterprise, and they kind of function, and they figure out how to get back to the good Enterprise. And when they get back to the good Enterprise, they're like, what happened to the bad guys, the bad Enterprise guys? And he said they went back at the same time or whatever. And he said, I was kind of confused. He said, we were over there, and we were wondering, like, what were they doing here? And I think it was Spock who says, he said, you as good people could act bad, but the bad people had no idea how to act good, right? And in a lot of ways, SQL and relational systems, they can be modified pretty easily to give a very simple API, to give a very clean, interface to, to people who need a very streamlined way of getting at their data. On the other hand, it's very hard for a simple system to add an SQL relational capability to it. So I would argue that Postgres bringing in JSON, GIS, these other new data sources happens pretty easily. We don't really have to strain very much to do it, particularly because we're an object relational system, so it was designed to be sort of add indexing, add data types and stuff, add operators and languages. So it's actually really easy for us to kind of bring in the simple stuff. It's a lot harder for a simple thing to try and bring in transactions and global consistency and snapshots and in a language like SQL. That's really hard. And it happens, sometimes they're successful, sometimes they're not. But it's a lot harder to go the other way.
Yeah, it is. Now, I would be remiss not to ask, because we, right now, PG-14 is going to be coming out soon. And, I'm curious, as someone who is, deep in the code base and, deep into the community, are there certain things that you're really excited about?
Yeah, I'm the guy who gets to write the major release notes, so it's usually a really I don't want to say painful, but painful process to read. It must be thousands of commit messages and then digest them down to something that everyone's going to be happy, sort of under, they're going to be happy with the way I phrased everything and the order I have everything, and that I've attributed it to the right people, and this phrase. And so you spend 10 or 12, 14 days kind of every day just kind of writing this thing. And then you finally put it out, and everyone's like, oh, this is wrong, that's wrong. And it's just the most, sort of the most depressing or sort of humbling experience to sort of spend all this time on working on this thing, and then have it sort of like, but once in a while you get somebody who says, thanks for doing it. They're like, we know it's really hard and we kind of beat you up over it, but we really do appreciate what you're doing. So, I think it's a good release. Surprisingly to me, we've been averaging, and I did blog about this as well, we've been averaging in the past 5 years about 170, 180 features in every release. This one is going to top out in the 220, 240 range.
Wow.
So I think it's 226, I think is the number. It's changing as we're, modifying slightly. But that's impressive. So it basically means that either because of COVID or because we have more companies now funding what we're doing, that we've actually, kind of propelled ourselves a little faster, in this release, which I think is kind of cool. So I'm kind of happy about that,
So if you were to pick one feature that you think is cool, or that you're like, that's my favorite.
Right. So the one that I think is my favorite is something that I think people are just going to be like, huh? A lot of people.
Well, we already know you like to say there. Hey, look at that train.
Yeah, look at that train. Exactly. Exactly. So probably the most interesting feature is the ability to clean up the indexes. So Postgres has kind of we've always had a problem with sort of cleaning up after ourselves, right? As you're deleting stuff, and you have to kind of fix it, right?
Right.
And the nice thing about this release is it has sort of the capability of cleaning up some of the old index stuff that's.
So is this optimization to the vacuum process? Or?
That's the thing. It isn't vacuum. It happens. So what happens is you've got let's say you have a B tree, and you've got a page that's almost full, right?
Yep.
And normally you split the page, and once you split the page, then you have two half-full pages, right? And very rarely can you kind of bring those back together. Like once you split a page, it's going to probably stay split. So you kind of want to reduce the number of times that you're splitting. So what this effectively does is it says if you are about to split a page, then check to see if you can remove some old rows in that page, in that index page, before you split it.
Oh, okay. So it's reusing space more effectively.
Yeah, but
cool.
The bizarre thing is it's kind of invisible, right? So like nobody's going to see this happening. It's just happening, right? So you're not going to really see people saying, "Hey, this thing is different," but it is.
Right.
But
I mean, those are some of the most important optimizations because you just don't understand them behind the scenes, but they make everyone's life easier and everyone will benefit from them.
Yeah, and the thing is that you don't even have to do anything; it just happens. Like it's not like a new keyword or a new whatever. This optimization is just going to be there. So everyone, you're almost all users are going to benefit from it, but they're never really going to know it's happening. They're just going to know that the system is more, is better than it was before. So, and there's changes, improvements in the indexing code. There are index improvements in how the optimizer handles long lists of constants. There's improvements in how we do partitioning. There's a good swath of stuff. There's a whole lot of new monitoring stuff that I was pretty impressed with. a lot of new system views. So yeah, it's a pretty cool release. It's got a lot of heft to it. Sometimes
Great.
there have been a couple releases where there really isn't a lot. This is a big one. I mean, it's going to have a lot in it, I think.
Great. Well, we look forward to seeing that. And Bruce, I wanted to thank you for stopping by and chatting with me. I do appreciate it. I enjoyed our time today. And if you want to check out Bruce's website, you can check out his personal website. You can also see him all over YouTube on tons of videos, including a couple Percona Live talks he just gave. Bruce has been out there for a while, so he's got a lot of great content. Bruce, final word?
Oh, thank you. I always enjoy the Percona events, and it's wonderful to catch up with you again.
All right. Thanks a bunch. Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.